Hello. Hi, good morning. Sorry. My name's Matt. Thanks for coming this morning. First thing to establish is that I am extremely old, and hence I've basically just been doing things for a long time. There may not be anything expert about what I have done. I've just done a lot of it. So that's kind of basically, I think, what Ben and Alex asked me to come and talk about is just all the things. So there's an element, there's maybe hopefully a string of coherence through it, but career is also a verb. So it's, there's a jumble of things in here. Alex asked me to sort of talk about my journey, windy as it is. So as I say, old. In the 1990s, I was at Cardiff University for about 5 years, and I studied to be an architect. And first of all, I was extremely terrible. Has any of you studied architecture, or anybody who studies architecture? Well, back then, one of the things you had to do was make a lot of models, physical models. And I was really terrible at it. So as a result, I taught myself to use CAD. And so I was hanging out a lot in the CAD room, the computer room, in the architecture school. And in about 1994, people were very excited about the internet. It was mainly sort of chat rooms and sort of news groups and things like that. And then in 1994, a thing called the web got invented by Tim Berners-Lee, and the first web browser, and I started making things on it. And so a lot of this is to do with just like curiosity and luck, as with most things. So just sort of being in that room and being exposed to that sort of thing led me to just making websites. And because it was the beginning of the web, I ended up sort of like making, I think, like one of the first 50 websites about architecture. There just weren't any. So as a result, people, even if it wasn't any good, which it wasn't, I'm very glad it's not around anymore. But I hope that none of you've got like good detective skills that you can dig it up, because it's bloody horrible. Anyway, I did this website, and it ended up like getting, featured in articles in architecture magazines about there's this thing called the web and all the rest of it. So I got again, just like luck and curiosity and circumstances. In 1994, 95, when I was graduating architecture school, there was a massive recession. So massive, particularly in the construction industry. No one was really hiring architects. So all of this like education that I'd put in 5 years, meant to do 7, but I sort of gave up. And after 5 years, decided to take a leap into technology, and sort of particularly sort of designing and building websites, which you had to do a little bit of everything back then to be able to put one live. So it wasn't really the separation between engineering and design that perhaps you sort of see in modern, the modern practice of such. So this is a bit of an edited timeline. In 1997, I was extremely experienced, 23-year-old. I've been doing it for 2 years. Come on, you can put me in charge of designing the BBC's first news website. Yeah, totally. Well, that's what I did. So I built a team there to do that, and that was again really sort of like wandering into a place where the rules would be, there weren't any rules, so you could start to like, experiment with what the rules could be or should be. So I did that for 2 years. Still very proud of some of the things that we did there originally. Then I went to work, my first dalliance with America. I thought, I guess I was about sort of, I don't know, 24, 25 at that point. It's like, right, I'm going to move to America. It's going to be amazing. And so went to speak to this company called Sapient. Well, actually went to speak to this design company called Adjacency, who I'd met the sort of founder of a couple of times, and just really liked them. They were like this small, really experimental, design-oriented company. They started off like making the first website for Specialized bikes and got paid in bikes. I was like, yeah, I was going to work for them. And then, so I was all ready to like move to the American Midwest to go and work for them. And the founder like called me up and said, Matt, I know you like put in notice on your flat and all the rest of it, and you're going to move to America, and you know, really, that sounds great. However, we just got bought by a really big company, and they're starting a London office, or they have got a London office, but they're starting a design team there. So I ended up not moving, but going to work for him, at a consultancy called Sapient, which still exists, but it's now like a big advertising. At the time, it was like a technology consultancy. It's sort of morphed over the last sort of 30 years, I suppose 20 years, into an advertising agency. So did that for a little bit. That was really good. Met loads of people who are still good friends of mine. And that was sort of, I suppose, that time, even though it was sort of only 2 years, that was sort of like my master's degree in something that you couldn't really study. And so I met loads of really, that was the first time I'd ever really met professional designers, I suppose. So lots of people who, particularly, at least in my experience, in America, in North America at least, design is incredibly professionalized and like very, you know, it's seen as like a very serious thing rather than like, you know, the sort of maybe through the 80s and 90s in London and the UK, design was a bit more, I don't know, punk rock or something. It was kind of like much more sort of, it actually came out, you know, most of the big graphic design names that you know would have come out of the music industry or their interface with the music industry, right? Whereas in the States, much more kind of like, yes, we've just been designing things for, you know, big companies for like 80 years and making loads of money doing it. So that was my sort of first exposure to that sort of very professionalized world of design, rather than something which is more perhaps out of the British tradition of sort of more art school, music, you know, creativity, whatever that is, side of it. America, much more professionalized, much more about delivering a service, you know, working to sort of business clients and that sort of thing. So that was like baptism of fire in all of that. And then went back for another sort of stint at the BBC for another 2 years. And that's where I first met Google, because I worked on the first search engine that the BBC ever did, first and last search engine. Back then it was sort of like, you know, we're the BBC, and you know, Britain deserves a British search engine, you know, rather than these bloody Americans coming over and all. So the BBC decided to make a sort of public service search engine, sort of more prioritizing kind of non-commercial content and those sorts of things. You know, pretty noble ideals for it. Of course, they had to power the thing with Google technology. So we went to visit Google in California. I think they were only about sort of 2 or 3 years old at that point. So it was kind of fascinating to meet all of the people who were like the founders really, and talk to them about it. And we were like wanging on about public service and like the BBC, and they were all like, yeah. And just like, has anybody ever, I don't know if you're probably so beautifully unaware of what modems are. Has anybody ever heard a modem? How it sort of like speaks, like that's what the Google people sounded like to me when they told us, like it was like you know, when you sort of phone. The other thing is like when you phone a wrong. This is like again like a pretty old person metaphor, but when you phone up the wrong number and you find that you phoned up the fax machine, and it starts trying to talk fax at you. that was what like going to visit Google was like as a designer. You just sat in front of these engineers talking like fax machines at you. So that was my first exposure to that. I think I've got better at speaking fax since, maybe. So I did that for a little bit, and then I moved to Finland. I went to work for Nokia, which again is like, once upon a time, were the kings and queens of the universe, and everything was, they basically dominated mobile phone technology, and you just heard the Nokia tune everywhere you went. Went to work for them, working on sort of like future concepts and stuff like that, which was super interesting. Moved to Finland. They interviewed me in May in Finland, and it was sunny and warm. And then I started in November, and it was not. So I did 2 winters in Finland, and then moved back to London, actually Farnborough, and worked there for a long time. And that's, first of all, where I started meeting a lot of people who were graduating out of a course at the Royal College of Art, which was running through sort of that early part of the 2000s called computer-related design. It was started by a lady called Gillian Crampton Smith, who went on to create a college about that time, 2003, 2004, 2005, called Ivrea in Italy. And that's where I think I sort of really found my tribe, if you like. People who were thinking about computation and software as a material, a bit like if you were a woodworker or a silversmith or a fashion designer. Like, you want to understand, you've got like visions and things you want to do, and a goal you want to achieve, but there's also like a fascination with the techniques and the material, and that speaks to you as well. And it's it's not neutral. It's not something that, it's got things it wants to do, so to speak, and things it doesn't want to do. And if you're a fashion designer or somebody who works in textiles, or, as I say, a woodworker or a metalworker, whoever it might be, those are the first things you learn, right? The first things you get taught as the sort of Lego bricks of what you want to achieve. And it's a funny, it's sort of that's a sort of recurring theme. I'll get to that a little bit later. So that's sort of the long and winding road to the actual talk. So I thought I'd talk mainly about work that I've done with friends at a company called Berg that we started, and then I'll talk a little bit about some stuff at Google. After I left Nokia, and it was very fashionable to do a startup back then. So we did a startup, or as they should be more reasonably called, tiny companies with no money, that you work in above a pub that has a day every Tuesday where they cook fish, and it really smells. So we did a startup called Doppler, which was sort of like a very, it was about the time that Twitter was starting, Facebook was starting, social networks were like we were trying to like experiment with social networks. We were doing it around sort of places and times and coincidences, like when would you and your friends be in the same place at the same time? So we were trying to make a social network which was more about the physical world and location and those sorts of things, a bit influenced by lots of things that we've been talking about at Nokia, about mobile telephony, not really being about phone calls anymore so much as, and that was sort of like the downfall of Nokia in a way, is like they didn't realize that a phone was going to have a new meaning. It was going to be something much more. And so a lot of it for me, as the sort of designer on the team, was about trying to almost, now that I haven't got a boss or a client, what are the things I've always wanted to try and do, that if it messes up, it's my fault, sort of thing. I can't blame anybody else. So it's like, what am I? It sort of forced me to sort of think about what I think and like do it. And some things were terrible ideas as a result. Some things I think still stand the test of time around some of the things that we did around interaction patterns, around social networking, which we sort of tried to do it very differently from Twitter and Facebook and those sorts of things. Some of the things around like using the web and web APIs as a way of pulling other services and other bits of data into an interface. Some of the things around InfoVis and sort of those sorts of things I'm still pretty happy about. But as I found this when I was looking to researching this talk, I like typed in Doppler to see if there was still anything anywhere on the web about it, and it's now like I think I can buy the domain back for like $2,000 from someone in China or something, and then like this is the startup cemetery. I didn't know this existed, but it's quite good. A big resource where we've collected why 100 big companies have failed. Also, really tiny ones like ours. Cause of failure, acquisition flu, which is a really nice way to say we got bought by Nokia, weirdly. Not weirdly, they were like, oh, you left us because we weren't listening. You went and made this thing. Can we like buy you back and do it? All right. By that time, I'd sort of left anyway. I'd sort of, in a way, because like, setting up and doing the initial design work was the thing that was exciting, and then the rest of it was sort of like the business. And I was like, oh, I don't know. So I didn't have to go back and work for Nokia for another 2 years as part of that thing, which was very good. So I ended up working, starting something with some friends of mine. So 2 friends of mine, Matt Webb and Jack Schultz, had been working together in an imaginatively named design partnership called Schultz and Webb for a couple of years. And I'd sort of actually been their client at Nokia. I just really liked the way that they thought and hanging out with them, and all of their stuff was very much around sort of thinking through making and this sort of like very material approach to technology. And so I sort of said, can I come and join you and like see if we can grow this thing? So we ended up like making a little design studio, sort of accidentally to start off with, and then deliberately much more, which we called Berg. Mainly because we couldn't agree on a name, and we asked a friend of ours who was a comic book writer to name us. Am I allowed to swear? Okay. We had lots of terrible ideas for names. The worst one, I think, was, and sorry if this is it is offensive, but we were so frustrated. We were like, why don't we call ourselves Shark Fucker? Just because we thought it'd be funny to go and talk to the business banking person at NatWest. And so we want, but we quickly shelved that idea. Apologies for the profanity, and if you're a particular lover of sharks. So we ended up being called Berg, which was a very obscure reference to a British science fiction TV show and set of books. Berg actually is an acronym. In this 1950s, 60s TV show, it was the British version of NASA, was called the British Experimental Rocket Group, and so that's what Berg stands for. But we ended up working for a lot of people in Scandinavia who thought, because in a lot of Scandinavian languages, it means mountain. So oh God, you egomaniacs, you've called your studio Mountain. Or it's like prog rock or something. But we're like, yeah, all right, it doesn't matter. Anyway, so I keep saying this is the beginning of my talk. This is sort of now the beginning of it. So the main thing I was going to try, like as a sort of thread or something that maybe it might be semi-useful, is this idea of exploring material as a place to start, simultaneously or sometimes before you start thinking about what you're actually trying to do. And we were pretty obsessed with this idea. We didn't really have much of a design process other than you have to do the material exploration before anything else. Like you have to understand what you're working with. Timo, another one of the founders of the studio, who's now gone on to, with Jack, start a games company called Playdio, who are doing really interesting stuff with AR and gaming. Is, as I say, it's like getting to know the grain and flaws of what you're working with, so you can like really exploit it and stretch it, and also get inspired by it. Jack, who's very, very tall. That's 2 stories of a building. No, he's very, very tall man. So this is from an interview which I'll send to Alex to send around, that they did, I think, about a year or so ago. And it's like this idea that it is about like true curiosity about the technology that you're working with, like having that curiosity that a woodworker would have about something they, just almost like an obsessive curiosity about technology, how it's made, what it does, how it breaks, those sorts of things. And I'll skip the whole thing of it, but it's this idea of like no one would design a building without looking at the land and the environment that it's set on and the materials you make. There's like this whole, in a weird way, user-centered design sort of like puts to one side all of that context that you're building with. And it's not that you shouldn't think about, making things that are useful and easy to use, maybe. Maybe you don't want to do that. Maybe you want to do something much more critical, something which asks a lot more questions. I don't know, particularly in the time and setting that you have here, that's the freedom that you have. But it's that idea that, it's a place, in industry at least, it's almost like prized over everything, that you're sort of delivering that easy interface to like create sort of business value. But in most other fields of design and creative output, there's an examination of, the material that, and the context materially that you're working in, the actual context you're working in physically, and then also the cultural context you're working in, right? So where does the thing that you're making land in reference to the cultural context, or the particular subcultural context you're working in? And we don't really do a lot of that, it seems, at least in commercial design for technology. Just to sort of try and give myself a bit of intellectual heft as I'm speaking at a college. This is one of the most, favourite's not the right word, because it's not, it's not like the Da Vinci Code, or it's not Harry Potter. It's not like something that you'd like, I must read more. But it was like, actually, it was quite good to read it. But one of the most impactful, I suppose, books on the way that I think about my work was this book, The Nature of Technology. It's a book by an economist about technology. And Brian Arthur, Harvard economist, and he was just curious about like why why technology in the technology industry is this like giant, crazy, huge success story, sort of, at least economically. Why do these companies create so much value, at least in sort of market capitalism terms? And so he looks at it in this like very forensic, like almost a bit like a zoologist looking at tigers, or it's like, why are they? It's not that he loves technology or he's in the industry. It's like, why does this thing work that way? I need to understand why it's so peculiar. And he sort of really, really does it from like, because he is such a sort of forensic mind. He sort of starts from like the very first principles of like, what is this stuff? So he starts at sort of like scientific phenomena. Somebody discovered, back in sort of the 1920s, 1930s, a number of phenomena were discovered by scientists in labs, whether it's like how to transmit information, or Claude Shannon, or stored program computing, John von Neumann, Alan Turing, how to make semiconductors, how to make chips. These, or like how semiconductors themselves, like there are these weird properties of these sorts of materials that mean that you can make these tiny, 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 tiny switches, right? Phenomena. And then on top of that is like, right, that's great. How do I actually build that? That's the sort of engineer's viewpoint on it. How do I build semiconductors, 1947, 50s? How do I build computers on top of that, 1960s, 70s? How do I build personal computers on top of that, 70s, 80s, la, 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 right? So this huge stack of stuff going right from phenomena. And so this idea of basically all value in technology is about capturing those phenomena and bundling them in some way. But it's also about like the combination of those bundles, which is sort of the design mind in a way coming into it. So this quote, which while I've been rambling, hopefully you've been ignoring me and reading. Invention falls into two broad patterns. It may start from one end of a chain from a given purpose or need, as I say, sort of like user-centered design, right? And find a principle to accomplish this, find the tools and the materials to do that. Or it may start from the other end, from a phenomenon or effect, usually a newly discovered one, and envisioned it in some principle of use. In either pattern, the process is not complete until the principles is translated into working parts. But he goes on to say, and this is a bit wordy, but as I was saying, like technology becomes complex of these interactive processes, a complex of captured phenomena, and they're all talking to each other. But it's not triggered in some like sequence like computing code. It's ongoing and continuously interactive. And I think this was sort of, in a way, this very wordy forensic quote by an economist was really what we were powered by at Berg, was this idea that there's all of these different phenomena and you can combine them in obvious ways, or you can be really stupid and combine, like we often were, and just try and see what happens when you move one thing out of the room it's meant to be, out of the box it's meant to be in and put it in another box. And really that is where the sort of material exploration sort of foundation comes in, is that you're able to do that faster and faster and more intuitively the more you start to have that kind of under your fingernailsness that a woodworker or a metal worker or a textile designer might have. So moving on from like wordy quotes to more relaxing, just watching videos together, which is the main thrust of what this will be, or GIFs. This is a very early project by Timo and Jack and some folks at Aarhus University in Oslo in Norway. This here that you can sort of see before the green measles go over it, this is the exact same component that's in the gates of the ticket barriers of an Oyster or any other kind of contactless interfaces, NFC reader. And as you know, Oyster and other things like that, and contactless payments and all of those sorts of things, very much sold on touch your phone to the gate. But it's not. There's not a pressure sensor in there, right? There's not a switch that's making a contact. It's a radio field. This is emitting a radio field, and that is sensing a radio field. And so it's not really about touch at all. It's about this bubble of radio being close enough to this bubble of radio, and the chip inside going, oh, that's a thing that we'll talk to the humans about as touching. But it's not really. And so this is what's really happening, and this is this kind of material exploration mode in a way. So in a accessible toilet in Norway, which in a similar to this place, very nice and new, and so you can't really like switch the lights off anywhere with a switch other than in the accessible toilets. That was the only place that was dark enough to do it in. They sort of mounted this, and what the wire that you can see coming around the back there is actually going to, need a prop, well, let's choose it, is going to basically a stick. Imagine this is a stick. And on the end of the stick is an LED. And the LED, when it's inside the detectable radio field, lights up. So you film that with a long exposure, and you start to, well, basically you poke it hundreds of times, and it lights up, you know, when it gets into the detectable field. So you're painting with light the actual properties of this technology. You know, it's as near as you can get, and as we're trying to make it as concrete and reduce the abstraction as much as possible with these experiments. And so you start, and the other thing about like these, you're making these images out of this and then sharing these images, is to try and sort of get into people, get the sort of these behaviours into people. You know, when you go and look at the oysters in, you know, Peckham Rice Station, hopefully now you'll see green mushrooms over all of them. You know, that's the idea, is like get it into your head with imagery rather than talk about all of the technology. You know, there's an actual truth to how the image was made, but the image is the thing that gives you the theory, the folk theory in your mind about what's happening there. So with the success of that, these two gentlemen, Einar and Bjorn, they teach at Aho, but they also run a consultancy called Voi Oslo, who do really lovely things. And they, with Timo, went on then to make a much bigger version of this. So these LEDs on this big stick are lighting up in response to Wi-Fi field strength. So same tactic, long exposure photography, not poking the field this time, but wandering around Oslo late at night, light painting the Wi-Fi fields. And so hopefully this will play. We won't watch all of it, but you'll get the idea. Is the sound?
You might need to select the HDMI output. It's bird dog.
Okay. Together in your head through these sorts of tactics, you start to wonder, you know, why is it dipping? You know, is it to do with? I think there's an image soon where you can sort of just in your head like make the intuition. Oh, that's gone down there because there must be, you know, something really blocking the signal there, or it might be. So you start to make up the rules in your head from the imagery. Rather than having to be told the rules. Anyway, you get the picture. Turns out Oslo is the sort of city where you can wander around at night with something like that and no one like arrests you or... It's kind of interesting, like the shadow of the car, like a big metal object affecting the radio, those sorts of things. Anyway, let's get out of that. back to this. So there's Jack again in one of our first studios, making another piece which was to do with this entire research program around RFID and we called a lot of this stuff about, but it's not really touch, but it's about nearness. So this film is called Nearness. It's a lot shorter, but very fun, and has an Oyster card in it. Who's familiar with a piece of work called The Way Things Go by Fishley and Weiss? It's a Swiss artist. Or sort of like, or less highbrow, sort of big domino rallies where, dominoes get knocked over and one thing happens after another. That's basically what you're seeing here, but none of all of the dominoes are radio, or at least on the electromagnetic spectrum. Nothing is touching, is the gag, which I've sort of given away, but you'll get it.
Yeah.
2009, still no iPhones. See, again, like trying to make fun, popular communications are quite technical ideas as part of this project around touch and RFID that was done in collaboration with Aho, as I say. Oh, what have I done here? Ah! Well done. I cannot use computers. Sorry. The next thing I wanted to talk about is sort of like this notion of using film, and mainly because we had Timo in the team, who's a brilliant filmmaker. We found ourselves using film an awful lot, or just the medium of like making videos. Some of them were like very rough, just like shot on our cell phones to kind of get the idea, like so, almost like sketching with film as well, sketching with video. And why why that was so important to us was just the element of time in interaction design, which is essentially kind of like the thing that you are working with more than anything else. And so the fact that you have to, if you're doing like a really sketchy film using your iPhone to film it, you have to act it out. You have to act it out in time with your hands, and so you get this like intuition, this sort of almost like material intuition about time and timing, in the same way that an animator or a filmmaker would have about what they would do in their craft. And so, as so much of interaction design is about kind of like what feels right in time and space, and hands and movement, film is, for us at least, was an incredibly important medium. This was a prototype we did in 2010 for a Swedish company called Bonnier, around sort of like they wanted to sort of explore like digital magazines. They're a publishing company, probably most famous for publishing popular science and sort of cookery magazines and things like that. And so we made this little video, all of which is kind of like based on a set of interaction design patterns that are pretty rigorously worked out. But we were prototyping this in video as well. So we were making little, as I say, sketchy versions of this with little paper prototypes and stuff, but videoing the paper prototypes in real time to like try and act out how it would work over a sort of a time base and get those timings right, even before we go into something much more polished than this. And of course, like the tablet is a block of wood with green paper on it to be able to register it in After Effects more easily. But rather than doing the After Effects as as you often sort of see a sort of abstract screen of a phone or a tablet or something in a sort of mask of a phone, we thought it was really important, even though it's a massive headache, to composite it on something in the world, because then you start to sort of see what it feels like to have it. If you go back to the beginning of that little clip, there's a behavior when this person picks it up off the table. There's something very lovely about that interaction. And a lot of it is about the ergonomics of it and how it feels. It doesn't look like a magazine, but perhaps it feels like one, is what we were trying to get to. The nice thing about this was it got seen by people at Apple who were about to launch the iPad, the first iPad at the time. And they were like, how do you know what we're doing? And we're like, well, we don't, but we know there's going to be tablets, and we know that humans have fingers. So, to an extent, right, you can sort of, it's like, these aren't changing for hopefully 100,000 years or so at least. So there are only so many things you can do with fingers and something that big. And the things that might be successful are smaller than that. So it's not that you're nicking it, like spying. It's like, well, people have fingers. So you're like, all right, fair enough. So we want you to build that for the launch of the iPad. It's in 10 weeks. We're like, it's a lie. It's a video. It's not real software. And they're like, yeah, but we want you to do it. We're Apple. Like, oh crap! All right then. And so we did it. One of the other things about this was the actual prototype iPad, of which there were probably like 100 in the world or something like that, probably 1,000 at that point, was given to Bonnier, who are a Swedish company, by Apple. That was where the deal happened. So we had to go and debug the code. Nick, the engineer who worked on it, basically had to fly to Stockholm, where the iPad was chained to a radiator by handcuffs, with a security guard looking over him while he was like sweating, debugging the C++. Anyway, that was maybe all worth it, because then.
And of all of the futuristic magazines out there, Popular Science is king of the hill. These guys did something really, really breakthrough. And if you haven't seen it, it's really worth taking a look at.
We got mentioned by Steve Jobs for 20 seconds. I will take that over anything else that I've done. Anyway, it made me very happy. Made us all very happy. Some more fun videos. So Steve Jobs, talking about our work, really great. The next video is something I never thought would happen in my design career, is having your work explained in a sort of sneering, sarcastic way, but actually very clearly and very well by Jeremy Paxman. Is it going to work? Oh, wrong one. I have to press play on this one.
That's all from Newsnight tonight. Before we leave you, an advertising agency called Dentsu London and a film company called Berg were playing around with tablet PCs recently in search of ideas and came up with this. You take an iPad and move it along while the screen flashes up a series of 3D letters as seen in cross-section like this. And if you photograph what you're doing on one single long exposure shot, it looks like this. So they made a movie of it, and here's an extract. Good night.
I still really love that work. You know, again, it's like taking something digital and playing with it and trying to get sort of like the material understanding of it, and then sort of trying to make it something that when you're looking at it, you're not quite sure what you're seeing, but you can sort of work it out. One of the other things that sort of like was really interesting about this project was Matt Brown, who was in our studio at the time, composed the music, and we sort of were curious about like, can we like put it on iTunes and try and sell it? So we trying to find out, like, a lot of the stuff that we were doing was also not just like curiosity about like the surface. You know, this is in a way like quite a surface, aesthetically led piece of work. But then one of the other things in the studio we were always really curious about were like the systems behind everything, and like some of those systems, like what does it mean to like, you know, how do you get music into the world now? Like, how do you put it on iTunes? How do you get it onto a streaming platform? We're not musicians, but we're really interested in like how this like big change has like affected that world. Can we figure out how to do that? This isn't. I'll show this very quickly. This is just another sort of. Well, I was digging through this, and one of my favourite things. This is like this is AR using train tickets. So the theory behind this was, we know that you're on the train, you've got a ticket, so we know exactly when you're going to go past things on the train track. So at 11:34, you're going to see this. So if you look at your tickets, you've got these little like deck of cards that came out with your ticket, and you're just a bit bored, and it's 11:34. You look out the window and you see the thing. But which is sort of like, there's a lot of effort to sort of do that. But it was kind of, again, sort of like, this was part of a bigger project about kind of thinking about connected printing systems and how you could use those to kind of like affect, you know, if you think about ticket machines as like print on demand machines that could like print you anything if you really wanted to. They mainly print you tickets to get onto trains. But why can't, you know, what else could they do? So that was like a really, anyway, that was one of my favorite things. I'm actually going to zip around a little bit. And just on that point of the systems behind things, we got to make a comic book, which was complete wish fulfillment on our part to an extent, where we sort of came up with the premise of the story, but then we got Warren Ellis, comic book writer, and you know, all-round brilliant writer of fiction and science fiction, to come up with a world and a story based on something that we were, again, like fascinated by, which was the beginning of AR, I suppose, and sort of like alternate takes on AR. SVK is a comic book about a secret bit of technology that gets invented by a sort of sinister technology corporation. Like, I won't mention any names of people I work for, but it sort of gets leaked and it falls into the hands of this person, who's a sort of mean-spirited, but sort of sort of a sort of modern Sherlock Holmes, I suppose. But we thought we'll like do printed AR. So when you buy this comic book, there are no thought bubbles from any of the characters. At least that's what you think. You read the whole thing without seeing anybody's thoughts. So in comic strips, you're always like seeing what people are thinking, right? Except we print all of the thoughts in UV ink that you can only see with a UV torch. But in the comic book, the magical piece of technology is called SVK, and it's a thing that allows the hero, sort of anti-hero, to see people's thoughts. That's the story in the book. There's a sinister surveillance technology that allows you to read minds, falls into his hands, and suddenly he can read thoughts. And you can too, because you've got the special torch that allows you to. So it's a lot of fun. Anyway, the main fun of it was this, which is UV ink. It turns out, again, material exploration, turns out if you want to do a project with UV ink, you have to be security checked by the authorities to prove that you're not forging banknotes. So we all got security checked. Then we had to go to the printers who were security checked. So there was only one printers that, oh no. There's only one printers that does it in the UK. They're the people who print the, they don't print banknotes, but they print all of the catalogues for Sotheby's and like art auctions and things like that. So like this amazing printing facility in Essex that we went to, which would be on this film if it were to stop buffering. It's a little bit disappointing. Anyway, you can go and look at that another time, more than the first 3 to 6 seconds of it. Oh well. So we're going to zip back from that. But the other thing about that comic book was we were actually sort of experimenting with the systems of selling things, because we had to sell. We didn't sell SVK through shops or anything. We sold it directly online. And at that point, we knew that we wanted to make and sell our own products, but we wanted to experiment with something that wasn't as complicated as like a piece of technology. So we sort of used that project of doing something really, really fun with comic books and like little torches that we got like manufactured specifically for it, to learn about like short-run manufacturing, and learn about warehousing, and learn about kind of like customer service and like returns policies and things like that, which, you know, are really, really boring. But you have to like be able to, that's again, part of the sort of systems design of like having to do these things. This is a project that we did for Google, which is again like, this was 2009, 2010. So this was like, again, experimenting with AR, but this was about kind of like computer vision looking at the world and then projecting the results into the world. So no screens, just projection. So as you can see by Andy's face there, there's a lot of measuring and calibrating how, you know, we've got a Connect there, we've got a webcam projector in a rig that we made to get the angles just right in order to have to make your own software to do any of this. And so what results from it, hopefully the internet's back. You know, we were having to sort of like roll our own everything really at this stage for doing computer vision in the world and projection and sort of AR maneuvers. So we did this with in collaboration with a brilliant Elliot Woods from Kimchi and Chips, brilliant technologist and creative technologist. And yeah, had to do everything by hand, which is like, and again, so like it's almost like the extreme of material exploration where you're like, oh God, you know, it's kind of like, if you're a metal worker or a woodworker, it's like, oh God, we have to go to the forest and chop everything down before we get it to the studio. Oh no, we have to grow the forest before we can chop the forest. So like this was like, oh, this is a bit too far. But it's just because there wasn't anything at the time. And of course now you can do it all in like AR Core, AR Kit. But you know, there's a little bit of that kind of, how far do you go? Like, what's the right amount of being curious about all of this stuff before you fall off the deep end into, oh God, I've had to become a, you know, software developer and like poke at things I didn't really want to have to poke at. Sometimes you have to, right? If you're trying to do something completely new, or, you know, AR Kit, you know, the tools that you've been given, which get you places really, really fast, don't do the thing you want to do, then suddenly you fall off another edge, right? Which is that you do have to go to the forest and chop down some trees. But this, you know, this ends up with kind of like some really, in doing this though, even though it was horrible, you know, you start to get that kind of like interesting insights from the sort of grain of material. I like the fact that this, you know, slightly janky version of AR kit that we were trying to make 10 years ago, like, is this quite organic, kind of unsure, wiggly line instead of like, you know, which, you know, we're all very grateful for as technologists and creative technologists now, but there was something quite lovely about the mistakes it made in those sort of like early pieces of work. At least that's what we tell ourselves, so we don't cry ourselves to sleep at night over the wasted hours and years. So that ends up with, again, sort of, how am I doing for time, by the way, Alex? Are we all right? Or sorry? Okay. I've got a few more things to show, but, you know. Okay, cool. So this sort of ends up with kind of like a design outcome of, we did lots of work around this, but one of the main design outcomes was like, what happens if you just have, instead of having smart things, you have smart light? So what if you have like video players that are just made out of blocks of wood with fiducial markers on them? So this is, it's quite hard to see in this light, but this is basically a functioning YouTube player that has no electronics in it. It's functioning by being seen by computer vision, and then the results being projected on the screen by a projector. So it's sort of like a weirdly cartoon extreme version of what's happening with cloud computing in a way, right? There's like nothing, you know, all that's happening on your screen most of the time these days are just pixels that are coming from somewhere else. This is sort of like the extreme. So this is like the scrubber, which is just a pulley that turns the marker to tell the machine vision to advance by so much, right? Sort of like very weird, extreme. This is a lovely one. This is a music player, and these are switches that are being completed, if you like. You know, the circuit is being made by making the visual symbol complete in the machine eye. We found a pigment that fluoresces in IR, which could be detected by the webcam. So we could paint those codes invisibly on an object. And then the other thing that we're doing is we're doing sort of like tiny projection mapping on these objects. And it doesn't look brilliant on a screen, but you have to sort of take my word for it. But when you see it in real life, it's like really, really spectacular. Looks really lovely. Anyway, again, sort of a little bit of a sort of provocation, really, rather than anything else. We didn't believe that the world was going to go this way. We just thought it would be funny to kind of make completely dumb objects that are brought to life and animated by smart light. And we were able to charge Google money for it. And eventually I got a job there, so they must have liked something about it. This one is another AR project. Early days of AR. This is about 2010, 2011, I think. Maybe, yeah, 2011. This is Swabue. These are, well, I'll let the video explain. Oops, which didn't work. Wait, play. So we were hoping to launch an AR toy empire at one point. One of my favourite things about this film is in the next bit. Pants contain environment. So the swappable pants on each of these characters. So their identity is the top part of the domino, if you like. The bottom part of the domino changes the environment that's then seen when it's mediated through AR. And this weirdly ended up in MoMA, in the Museum of Modern Art, in an exhibit, which was really not what we'd intended. We intended to like invent the next Pokemon and become bazillionaires somehow. But unfortunately for us, that didn't happen. The advertising agency we worked with did actually left London, moved back to Tokyo, and it ended up in the Museum of Modern Art in New York, which is fine, I suppose, but not what we intended. But really lovely little project that. So we went on to, right, here's how we're really going to be millionaires. We're going to make a tiny printer. And so we spent a lot of time and effort working on this guy. So it's a tiny printer that sort of gives you the equivalent of like scrolling through your phone every morning on a sort of basically using the printer that's in shop tills, which is an incredibly cheap component. So we saw it as like a quiet alternative to like being engrossed in your phone, and it prints its own face. And its face changes every day, like a Tamagotchi, and you sort of take care of it. It's sort of like a character of its own. And so this was like also, this was a product that was also an experiment into a lot of different things. What's it? This was the time when people were starting to talk about Internet of Things. What does it mean to make a thing that you want to have in your house that you sort of treat like a piece of furniture or a character rather than as a piece of technology? Can we make it? Can we sell it? Can we make a platform that this all runs on? Can we get partners to work with us on this? So there were a lot of agendas in this kind of like quite charming, odd product, and it was incredibly complicated and hard to make. The real sort of the strategy behind that was Berg was turning from a sort of design consultancy into a product company and into a product technology company. And what we wanted to eventually become millionaires from was the sort of IoT platform that we were, this was sort of like the Trojan printer that the platform would kind of come from under. And so actually, I won't dwell on a little printer. I wanted to actually show some other things which sort of came from the platform side of it, which perhaps aren't as well known in that any of our stuff is well known at all. But so these are two projects which sort of are based on the platform. One is, I think, I wish this existed still. This is Pixel Track, which is a signage system. But it's a signage system that is basically a display.
Berg's been working with the Future Cities
I'm
Catapult,
going to
researching
Jack up.
industrial design for new clients.
And Pixel Track is effectively a little toy train that instead of running on train tracks, it actually changes the track that it's on. So there's a lot of research into making mechanical pixels, basically, and this is where we net it out, which is something where the train is flipping over pixels with a little sort of print head that it has as it goes over the track. So you can make the idea is you can make the pixels incredibly cheaply, and they don't require any power. So you can put them in places where you know, you don't want to use a lot of power in public spaces, in, you know, libraries and hospitals and those sorts of things. And this little train, as you can see, flips the pixels over each to create the display. Really lovely, and sort of running on the platform. Second one I wanted to show you is a washing machine, and this is again sort of trying to prove out the platform, and this is where we're sort of trying to show the value of what we've invented to people like Bosch and Miele and Whirlpool. So you can prototype these sorts of interactions really, really quickly. So you just put, this is the board that we made for our sort of IoT platform. And you can start to prototype interactions using connected apps really, really quickly. And this, you know, this was a real thing. And then we can start to also, further on in the project, we're talking, you know, then that leads us to sort of how quickly can we prototype new interfaces and new interactions for, you know, things that don't have screens or shouldn't have screens, domestic appliances, those sorts of things, and make them sort of connected experiences. So you can watch that at your leisure. Again, sadly, the world of washing machines was not ready for us. So a little bit ahead of our time, maybe. And at that sort of time, you know, Berg had transitioned from being a design consultancy to a product company, and so we had taken VC, we'd taken investment to try and, you know, push this idea of an IoT platform. Sadly, didn't work out, and as you know, we moved from being a consultancy model to something where we were a startup model and we ran out of money. And so Berg closed its doors in about 2014, by which time I'd left. Which leads me to the final chapter. So from 2013, after working with the Creative Lab at Google on things like that Lamps project and then being familiar with Berg, etc., two things happened, actually three things. Two things arrived, which are my children, and suddenly a salary became something that grew quickly attractive to me as a human being. As a result of you know, being in sort of startups and interesting design studios and things like that was great. But then, yeah, big technology came a calling. I moved to New York initially, went to work for Google in a bit of the company called Creative Lab, which is sort of an odd offshoot of the marketing department, basically. And it was full of people who I'd never worked with really before, from more of the advertising and creative communications world. People who filmmakers who come much more from marketing and narrative, copywriters. I never worked with like writers before. That was amazing. Writers are incredible. They're writers are the fastest designers, because you know, the really good writers can just conjure like a world in your head with a sentence. You're like, oh right, yeah. Oh, I was gonna like do all of these prototypes for that, but that's exactly what it should be. And it was so I spent about 2.5 years doing that. Just quickly show you two films that we made, like two projects from there. And these are sort of like films, the character and tone of the films that you've been seeing from Berg are in marked contrast to what you will see from the marketing department of Google, as a very big tonal change is about to happen. But with that...
So there's this giant power plant in the sky, and it's creating free energy for anyone to catch. But most people aren't catching it, because even though it could save them money on their electric bills, getting started can be pretty frustrating. There's all this stuff to figure out, like How many panels do you need? Who's gonna install them? How much would you actually save? And how do you tell if your house even gets enough sun? A lot of people ask Google these kinds of questions. So we started looking for a better way to give them answers. And that's when one of our engineers got an idea. If people are getting lost trying to find answers about solar, why don't we give them a map? We could take the information that's already in Google Maps and use it to show how much sunlight falls on a roof. Then we could combine that with all the other stuff people need to figure out and create kind of a treasure map of solar energy. It could show you how much solar power your roof can generate and how much you could save. Then it could even point you towards an installer in your neighborhood instantly. It's an idea we're calling Project Sunroof. And right now, we're just starting with a few places, like Boston, where the Sunroof team is from, the San Francisco Bay Area, where Google is from, and Fresno, where one of our engineers' mom is from. Pretty soon, it'll grow to include the entire country, and maybe even the whole world. That way, anyone, anywhere, can start catching energy from that power plant in the sky.
So, I got to it with like brilliant animators and scriptwriters. They didn't let me anywhere near these sorts of things. I was probably like one of the first product interaction designers that they'd sort of employed, so I was a bit of a weird fish in there. But I was working with the engineers who were featured in that about this idea, which was like still to this day like one of these like brilliant one in a million ideas of like, well, we've got all of these maps, and we can actually use basically basic geometry from and machine vision on top of those maps to understand the angle of people's roofs and where the sun will be, and make a model of how much sun is going to be falling on that roof. And so like a brilliant, again, sort of like piece of material exploration in a way, like understanding what you've got, but then like recombining it to come up with something really brilliant, which is still going to this day. I think it's in the UK now as well by this time, not sure. I'm going to skip over the next one in the interest of time and talk a little bit about this. So when I worked in that department in marketing for about 2.5 years, and then moved over to Google Research, and particularly sort of AI research, about 3.5 years ago now. And this was one of the first products I worked on. And if I'd remember, I have one of these at home, and I forgot to bring it in. Apologies for that. I'll bring it in another time that I visit. But it's a camera. It's a camera that also has a photographer inside. So there is a tiny AI inside this that has been trained on things that most humans like. Most humans like other humans. Most humans like other humans when they're smiling, those sorts of things. Most humans like puppies and sunsets and things like that. So out of the box, this device knows that if I'm put in front of a smiling human and a puppy, my owner might like that, take a photo. This button is the only button on the whole thing. That you can switch it on and off by turning the lens, but this is the only other interaction. That is a button that looks like a shutter button. It sort of is. It's also a voting button to the AI to say, I like this. So you've taken a photo, but you've also voted. You've also said to the AI that's inside there, I like sunsets reflected in the grimy puddles of Peckham Rye. And so it would train the neural net that's inside this to remember that, to activate next time. So the idea of this as a project, again, it was a product that was sold for a little while by Google, but it was really also an experiment to prove a couple of things. One is that the advantage is the value of AI doesn't necessarily have to be in the hands of the corporations that make them. It can be in your hands. So this is a device which is like this big, that is self-contained. It's an AI in a device, on-device AI, which is predominantly what the group that I work with has been researching. So you're actually putting the computing and the neural networks and the ML systems inside the device. This could go for, years without talking to the network and still behaving and learning in the way that I've described. It's also your AI. It's, your model of what you've been voting on and teaching it is yours. It's not an averaged, it comes out of the box with, I think most humans like puppies. But once you've trained it, it's yours. And it's that kind of principle of, being a manufacturer of billions of AIs rather than just a maintainer of one giant AI in the cloud, which is the kind of research agenda behind this project. And this is a trend which is continuing the genesis of this was in around 2015, 16. And so this has been continuing. I'll skip over a bunch of it. I think you're all pretty familiar with Teachable Machine and things like the marshmallow sorter. Have you seen the marshmallow sorter? Okay. Well, the marshmallow sorter is actually built on Teachable Machine, but it's also built on hardware components called Coral, which is an output of our team as well, which are development boards for prototyping things like Clips. Clips was like can we do this? And then Coral is like, right, can everybody do this? So it's a little bit of a connection back to some of the things we were doing at Bird Cloud. The last thing I wanted to show is some work that I haven't really shown that much outside of Google, which is about, my last 2 years have been doing a lot of research and design research around agents. Rather than, if you think about like Siri or Alexa or the Google Assistant, you have this kind of like this paradigm at the moment of sort of like voice assistants and sort of things which are effectively sort of intercoms you're basically like phoning up Apple or Google or Amazon and asking for something. And then Apple, Google or Amazon are doing something for you. They're rendering it as a service back out through the speaker, back out through whatever it might be. So in a way, there's an element to it where, there's a lot of AI involved perhaps in like understanding what you're saying. But after that, it's really kind of business as usual. When you think about agents, and agents have like a large component of this kind of personal AI within them. So what I was describing with Clips, that once it's yours, right? It's your agent, it's your device, it's your model, you're training it. The value of that training is yours. As soon as we leave the shop with our two agents, our two personal AIs, they're going to start to, yours is going to start to become yours, and mine's going to start to become mine. There's going to be some things that they sort of do kind of the same probably, because we probably both like to catch buses on time and things like, but there's other things where it's going to diverge a lot. And so this agenda of personal AI and personal AI agents is what we've been looking at for the last 2 years or so. And one of the things that we've been looking at a lot is kind of the idea of moving from this kind of like quite, again, like the overriding drive behind Siri, Alexa, Google Assistant is just tell me what you want and I'll, don't worry about it. I'll magically do it and get you a result, which is, a lot of the time good and a lot of the time very useful. And, saves you time, saves you headaches, whatever it might be. But there are things where you don't want that. You want it to be more like co-piloting, or you want it to be something where it's more kind of that it's augmenting you doing something rather than it's automating something away from you, if that makes sense. So a lot of our work has been sort of like looking at trying to create a spectrum of how we also tend to talk a lot more about owners rather than users when we're sort of just to sort of remind ourselves of the fact that of a relationship that you might have with this thing, that it's kind of very much yours. But kind of, there are going to be sorts of things where it's very low risk, there's very high confidence on behalf of the agent that it can deliver something for you. Tell me when the next bus is. Yeah, I can do that. Totally automated, high confidence, low risk. But there can be a load of things where the agent is going to have low confidence that it can do a good job on that, maybe the first time around. It's going to be kind of high risk. Perhaps it's like a high risk context for you personally. And so, you should just admit that there's going to be a lot more input required by the human part of the partnership, if you like. But you want to be able to shift gears and go back and forth up and down this spectrum. And that's a lot of what we've been working on, are sort of UI patterns and technologies that allow us to not just do this kind of like voice assistant, personal assistant model over here, but also do things which are much more like AI agents co-piloting complex tasks with you, and then a bunch of things in the middle. And just one sort of like little example of that is sort of a little bit of a trivial one, but it's kind of interesting. We did this with a little company who are up in Hackney Wick called Nord, 3 people, brilliant design prototyping shop. I've done a lot of projects with them. And one of the things about these kind of like personal AIs is we could probably train them to do lots of very objective things, like things where there aren't sort of like value judgments involved, as it were. But one of the nice things that may come with this being more of a personal model is it can start to learn more subjective things about you, which is something that wouldn't feel particularly comfortable with a big technology company doing that, perhaps, but something manufactured by a big technology company that then is yours and is private to you and can't be introspected or inspected by anyone other than you. Perhaps you would like it to learn particular things about how you like to do things, right? So does the change, what we're trying to examine here, not just in the sort of like UI patterns, but also in the attitude to the technology, does the change in the architecture that the technology allows you to push, rather than it being in the cloud, being in the data center, maintained and owned by a private company, you have a company that's making something for you and then it's yours. Does that change your attitude to how you relate to it? How would you know that it is truly yours? How do you trust it? How would you test it, check it, make sure that it's got your agenda rather than anybody else's that it's working to? All sorts of things like that we've been doing loads of research around, but just to bring it back to GIFs of interfaces, thinking about subjective tasks. This is a visualization. So, this is not like a particularly, this is a pretty, everyday, mundane use case, like trying to find something you want to wear. And doing this is something where, this is something where you're going to have a lot of subjectivities brought into it. There are some objective things like, how much is it? Is it going to arrive in 2 weeks' time or 2 days' time? Is it made out of natural materials? Is it ethically sourced? So there are things that you can sort of just the agent can sort of tick the boxes of. But there are going to be some things where, like, what's I want something a bit, adventurous, or I want something a bit minimal. Like that's, my version of adventurous and your version of adventurous will be very different, I hope, for you. So they should be different for everybody, right? And so your agent should be able to be trained in what you mean by those subjective things to help you sort of search, this large space of tops that are flicking up there. So this is a visualization of that, which is this is sort of co-piloting surface or a co-piloting UI, where it's being drawn in real time by an AI, and you're manipulating in real time and sort of also able to train it. So the second part of this UI is that each of these purple bubbles is one of those sort of subjectivities, and you can train it. So you go to this next interface, which is a bit like a sort of mood board, Pinteresty thing. And by just training it on something like, doesn't need like very many data points. This technique that has been researched by colleagues of ours, computer scientist colleagues of ours, called concept activation vectors, or CAVs, becomes really interesting and important. So CAVs are a technique they were researching around being able to explain what machine learning models are doing. Like, why is this model, it's like a big topic. Why is this ML system doing what it's doing? Is it biased? Is it excluding people? Is it returning unfair or biased results because of the way that it's been trained? So one of the very active fields of research in Google Research are around these topics around explaining what ML systems are doing and being able to like diagnose them and fix them, if you like. And CAVs is part of that. But we sort of talked to the computer science and said, this is going to be really great for us being able to explain a personal model back to an owner and having them train it. And it also turns out by using this technique, you can train it incredibly quickly with like not very many data points. So you sort of like add and subtract a few things from this mood board, and it learns on device. So this again is a personal AI. This is a personal machine learning model that's training on your phone, doesn't go anywhere else. So your adventurous is your adventurous on your phone, different from yours. And so we've trained it with like this nice little fun interface. Takes about a minute to do, and then you can start piloting around this space with your agent that now knows what you mean by adventurous or minimal or glamorous or something something very subjective, and can sort of help you wander around and augment your ability to kind of search a very large space. So sort of trivial example, but something that we're really excited by around like a fundamental computer science research output, then being able to be applied into kind of like an interesting, useful, probably, hopefully valuable in something like a shopping search engine thing, but also has like quite what we think kind of is trying to do the right thing around kind of personal privacy, agency, trust in these sorts of systems. And again, sort of coming out of trying to do sort of like material exploration around what CAVs are and what this technique is. That's it. Thanks for paying attention.